Okay, so moment. We need to define moment. يلا احنا if we want to define moment, how can we define moment يا شباب? Moment is the turning effect of a force. So it's the turning effect of a force about a pivot. يلا this is the turning effect of a force about a pivot. About a pivot. Okay. طيب يبقى first of all you need to have a pivot. You need to have a point at which an object will rotate around. Okay, about a pivot meaning that the object will rotate around this point. It could be a pivot, it could be a hinge, whatever point that doesn't rotate. So there is always a point on the object when it's rotating. There's only one point in the object. This point actually doesn't have to be in the object. It could be يعني below the object. But this point means that in هو المومنت أو the whole object will start to rotate أو will start to turn around that point. Anyway, moment, how can we calculate moment يا شباب? Moment is the force times the perpendicular distance. Force times the perpendicular distance, and the distance has to be perpendicular. Why? If the distance was parallel, it wouldn't rotate, it would move, and hence we would be actually calculating the work done. Later on, we will talk about work done, which is force times distance moved. But for the moment, you need to find the force times the perpendicular distance between the force and the pivot. It's not just any distance. This distance is between the force, between the force and the pivot. يلا, and the pivot. طيب. يعني if we have an object, if we have, let's say, a beam. Okay, yeah, this is a beam. One of the most common questions is that they give you a beam, okay, and the pivot is at the center of this beam. If the pivot is at the center of the beam, it would be an easy question. Why? Because you would ignore the center of mass. Because you would ignore the center of mass if the pivot is at the center of the beam. Why? Because the center of mass is acting directly above the pivot, so no moment is exerted by the center of mass. But a more يعني a more difficult question would be if the pivot is to the left or to the right of the center of mass. Therefore, the center of mass would exert a moment. يعني for example, if I have the pivot at this point, okay, if I have the pivot at this point, and I'm saying that this is, let's say, a 100 centimeter ruler. This is a 100 centimeter ruler. Whenever I say it's a 100 centimeter ruler, the center of mass would be acting exactly at the middle, at the center of this ruler, which is at 50 centimeters. So at 50 centimeters, okay, is the center of mass. Center of mass. Yeah, at this point would be the center of mass, which is the weight, which is the weight. Weight is a force which is always acting downwards. So it's a force which is always acting downwards. At the 50 centimeter mark, for example, the pivot is at the 30 centimeter mark. So it's at the 30 centimeter mark. But what about if we have another force acting at the, let's say, 90 centimeter mark? It's an upward force at the 90 centimeter mark. Let's say this force is what, 10 newtons, for example. The weight in this question is 50 newtons. Okay, 50 newtons. And then he's asking, is this object in equilibrium or not? Is this object in equilibrium or not? I don't know. How can I find out if the object is in equilibrium or not? Equilibrium means that we must satisfy two equations. Okay, equilibrium. Equilibrium. Okay, it means that I have two things that that must be satisfied. First of all, I have to say that the clockwise moment, yes, exactly, is equal to the anti-clockwise moment, or that the resultant moment is equal to zero. That the resultant moment, resultant moment is equal to 0. Meaning, in other words, you can say that the clockwise moment is equal to the anti-clockwise moment. صح. طيب, the other condition that must be satisfied is that the resultant force, the resultant force is equal to 0. Meaning, okay, that the upward force is equal to the downward force. Resultant force equals 0 means that there is no turning effect. Turning effect is 0. Resultant force equals 0 means that there is no motion, no acceleration. The object is at rest. The object is at rest. So equilibrium, okay, in moment, when we're talking about these questions, you must satisfy these two conditions. Resultant moment equals 0, resultant force equals 0. For this question, for example, I have this beam. Can I find out if it's in equilibrium or not? Yes, I need to first of all find the clockwise moment and the anti-clockwise moment. Type. Let's see. The center of mass, it's acting downwards. Will this force exert a clockwise or an anti-clockwise moment? Yeah, just take the force and go to the pivot. This is clockwise or anti-clockwise. This is a clockwise moment. يلا, I'll write down that this is a clockwise moment. طيب, what about the force? يلا. This is an anti-clockwise moment. طيب, let's calculate them. The clockwise moment is force times perpendicular distance to the pivot. خلي بالكوا, to the pivot. It's not 50. The distance is not 50. Distance between the center of mass and the and the pivot is what is 20. It's 50 minus 30. So the clockwise moment, يلا, force times perpendicular distance, meaning that the force is 50 newtons times the distance, which is 50 minus 30. 50 minus 30, which is 20. صح? So the clockwise moment is 1000. Type. What is the unit of the moment? Moment. Force perpendicular distance, so it's Newton dot. This is 100 centimeter ruler, so Newton dot centimeter. It could be Newton dot meter, Newton dot centimeter, Newton dot millimeter, whatever. صح, بس Newton dot something. You could ignore the dot. Sometimes you could ignore the dot. So Newton meter, Newton centimeter, or whatever. طيب. What about the anti-clockwise moment? يلا, anti-clockwise moment. Force times perpendicular distance. يلا, force times perpendicular distance. The force is 10 newtons. And the distance, يلا, distance from the 90 to the 30. يلا, to 90 to 30 كام? 60. صح? 90 minus 30. Which is 600 newtons dot centimeter. طيب, يعني this beam, it's not in equilibrium دلوقتي. It's not in equilibrium. Which moment is greater? The clockwise moment is greater. By how much? By 400 newton centimeters. So the clockwise, this beam will now rotate in a clockwise manner. It will rotate in a clockwise manner by an amount of, let's say, 400 newton centimeters. Can I add another force? Can I add another force to make this beam in equilibrium? Yes, I can. Yes. You can add a force. If I didn't specify the distance or the force, you can add a force at the distance which you like, at whatever distance which you like, okay, to make this beam in equilibrium. يعني ايه؟ دلوقتي you need an anti-clockwise moment. You need an anti-clockwise moment. So this anti-clockwise moment, it could be either on the left side or on the right side. This anti-clockwise moment could act at this point, for example, or it could act at this point, مثلا. صح? So it couldn't act on the left side upwards and it cannot act on the right side downwards. Why? Because if it was on the right side downwards, it would be clockwise moment. If it was on the left side and upwards, it would have been it would have also been clockwise. So مثلا let's say in the force is on the left side. Let's take the force to be on the left side. This is the new force that I will add. It's a new force that I will add on the left side. I need it to be 400 newton meters. يعني, for example, if I say at a distance of 20 centimeters from the pivot, If it's at a distance of 20 centimeters from the pivot, 20 centimeters from the pivot, meaning that it's at the 10 centimeter mark. صح? It's at the 10 centimeter mark. طيب, at the 10 centimeter mark, the distance is 20. I need to add another another anti-clockwise moment. Huh? Force times perpendicular distance. The perpendicular distance is 20. صح? طيب, 20 times what would give you 400? 20 times 20. صح? 20 times 20 newtons. So 20 newtons times the distance of 20 would give you 400 newton dot centimeters, and therefore this beam would be in equilibrium. It would be in equilibrium. Why? Because you have two forces that are exerting an anti-clockwise moment, and only one force which is exerting a clockwise moment. And they are now equal. Type. We satisfied the first condition, which is that the clockwise moment is equal to the anti-clockwise moment, that the resultant moment is equal to zero. This is the first condition. Now, what about the second condition? Is it satisfied or not? Is the second condition satisfied or not? دلوقتي we have 20 newtons and 50 newtons, but we have 10 newtons upwards. صح? We have a force of 10 newtons upwards, we have 50 newtons downwards, and 20 newtons downwards. Let's just write them down. Okay? The second condition says that the upward forces should be equal to the downward forces. Forces. Now, what are the upward forces that we have? From what I see, I only have one force, which is F, directed upwards, 10 newtons. The downward forces are, we have 20 and 50, which are 70. So 20 plus 50. It's quite obvious that they're not equal. And here 70, and on this side 10 newtons. We're missing something. We're missing what? We're missing 60 newtons. Type, where does this 60 newton act? These 60 newtons act at the pivot. They act at the pivot. Type, they act at the pivot. We'll call this force R. We'll call this force R, which is a reaction force. So the 60 is a reaction force. Where does this reaction force act? It acts at the pivot. Usually it acts upwards, okay? Because if the forces are downwards, therefore you'd have a reaction force acting upwards, okay? So usually most of the questions related to moment, okay, you usually have a pivot and a beam. You'd have three forces, okay, two of them clockwise, one is anti-clockwise, or the other way around, and then he'd tell you to find the missing force. He'd ask you to find the missing distance or whatever, okay, and then the next question, part B, he'd ask you to find the reaction force or the missing force, or okay. So you need to use these two conditions. Resultant moment equals zero, resultant force equals zero. Clockwise moment equals anti-clockwise moment, and upward forces are equal to the downward forces. Okay? طيب. Now quickly moment, and then usually some questions related to moment are when they ask you about the stability. When they ask you about the stability of an object, if an object is stable or not, or how can you increase the stability of this object, or how can you decrease the stability of this object, okay? So the stability has to do with two things. It has to do with the area of the base and the distance between the center of mass and the ground, okay? The area of the base, okay, and the height or the distance, whatever, it doesn't matter, the height of the center of mass, of mass. So whenever you increase the area of the base, the stability increases. It's directly proportional. But whenever you increase the height, of the center of mass, the stability decreases. It's inversely proportional. So basically, you want the height or you want the center of mass to be closer to the ground. Okay, you want the center of mass to be closer to the ground to increase the stability of this object. If I get two objects, for example, okay, I have a very thin rectangle and I have a very wide rectangle. So both of them have the center of mass. Their center of mass is at the same distance from the ground. Oh, this is the center of mass, okay, and this is the center of mass. So the center of mass is at the same it's at the same distance from the ground. But what differs is that the second object has a wider base, so it's more stable. This has a wider base, huh? So it's a more stable, wider base, so it's more stable. But what if I change the center of mass? What if you change the center of mass? For example, if you have two objects, um, it's the same object again, but I have another smaller object with the same base. So it's the same area of the base. The center of mass is very high up, but this center of mass is very close to the ground. Now, this is more stable. Why is it more stable? Because the center of mass is closer to the ground. So center of mass is closer. Oh, center of mass is closer to the ground. طيب يبقى it's more stable. طيب tipping over an object, okay, or toppling over an object. What does toppling mean? It means that this object will tip or it will fall on its side. Okay, if I have an object, I want to topple an object. Okay, toppling. I think there's an E somewhere there. Doesn't really matter. Okay, so if I have an object, let's say this is the ground. Okay, let's say that this is the ground. Like, if I have an object which is tipping over just a little, okay, this is an object which is tipping over just a little, and this is the center of mass of the object. How would I know that this object, if how would you know whether this object would topple over to its side, on the right hand side, I mean, or not? Whether it will topple over or not depends on whether the center of mass crosses the base or not. صح. Center of mass, huh? The center of mass, whether it crosses the base or not. يعني إيه crosses the base or not? All you need to do is draw a straight line from the center of mass, okay? Straight line downwards. Straight line downwards. طيب. This line is now crossing what? It's crossing its own base. So it's crossing the base of the object. So this object will now topple to the left. يعني it wouldn't topple, it wouldn't be tipped over. Okay, it will be stable, kind of. It will be stable. But it will not tip or it will not topple over to the right side. لا, it wouldn't topple over to the right side. طيب, what happens if I increase the angle? What happens if you increase the angle? والله, if I increase the angle this way, okay? لا, this object will definitely topple over to its side. This is the center of mass. And if you draw the line of center of mass, this red line that I'm drawing, it's called the line of center of mass. So if the line of center of mass, let me write it down, the line of center of a mass. If the line of center of mass crosses the base, okay, to another base, خلاص يعني the line of center of mass is on the other base. What happens is that it topples over to the side. خلاص؟ طيب يبقى this will topple over to the right hand side. طب how can I make it in equilibrium? Okay. Can I let me draw another object. Can I draw an object كده? Okay, let's assume that this is a perfect square. I know it's not a perfect square at all, but I'm trying to assume it's a perfect square. And this is the center of mass of this square. If I draw the line of center of mass, and the line of center of mass doesn't cross either base. Actually, the line of center of mass is exactly above this point. And this is a very critical point. Why is this a very critical point? Because this is the pivot. This is the pivot. So if the line of center of mass is exactly above the pivot, the line of center of mass is exactly above the pivot, what happens يا شباب? It will stay. It will remain as it is in a perfect world طبعا. يعني technically technically you can balance the pen or the pencil on your hand. You can do that. Technically, you can do that. But due to the vibrations, due to some wind, due to whatever, it will tip over to either side. So in a perfect world, yes, I can balance a pencil. I can balance any object. You can balance any object on a point, on some certain point. When can you balance this object on that point? It's when the center of mass, okay, or when the line of center of mass exactly crosses or is exactly above the pivot, is exactly above the pivot. That's it. So this object is now in equilibrium. It wouldn't topple over. It wouldn't tip over on either side. No, it is in equilibrium. Why? Because the center of mass is exactly above the pivot. The clockwise moment is equal to the anti-clockwise moment. Thus, it will not topple over. This object is in equilibrium. Okay? Equilibrium. For the first object, you can say that the anti-clockwise moment is greater than the clockwise moment. For this first object, you can say that the anti-clockwise moment is greater than the clockwise moment. For the second one, you can say that the clockwise moment is greater than the anti-clockwise moment. For this one, they're both equal, that the clockwise is equal to the anti-clockwise moment. Okay, I hope it's all clear دلوقتي. Uh, the moment, center of mass, toppling, stability of an object, whatnot. طيب, any questions up till now? Um, okay, good. طيب, يلا بينا. Let's solve a couple of questions. Let's solve a couple of questions. Paper 4. Let's open up moment in paper 4. Oh, last question, moment, page 159. Last question, page 159. كله جاهز؟ يلا بينا. Let's go. 159. I have a radio transmitter. Okay, that's a very tall, thin cylinder. It's prevented from falling by the wires مش عارف ايه. Um, G is the center of gravity or center of mass. So G is the center of gravity or the center of mass. He needs you to write down what is the center of gravity. What is the center of mass? I've been saying center of mass, center of gravity, center of weight. What is the center of weight? It's a point at which all of the mass or all of the weight or all of the acts. Okay, it's not not all of the mass or not all of the weight is exactly at that point, but we can consider you can consider all of the weight to act at that point. Okay, so what is the center of gravity? It's a point at which, okay, a point at which all of the weight of an object, all of the weight of this object is considered to act. Center of mass, center of weight, center of gravity, they're all the same thing. Explain why the radio transmitter without the wires is a very unstable structure. Why is the radio transmitter a very unstable structure if you remove the wires? Why is it a very unstable structure? Allah, it would be very unstable. That's quite obvious. Why? Because of two things. Because of two things. Bravo عليك, yes, high center of mass. The center of mass is very high up. High center of mass. Or you could say because it has a very small area. Yes, it's very small base. The width of its base is very, very small. Okay? It could tilt very easily. صح؟ Yeah. Center of mass is very high up. Very high up. Or you could say that it has a very narrow base. Okay, it could tilt easily. Okay, طيب. يلا. Wire W is under tension and exerts a force T on the transmitter. Wire T. Okay, wire W is under tension and there's a force T on the transmitter. This wire is exerting a force. This force, now we will call it T. Tension. Okay. On figure 4.1, mark an arrow to show the force T exerted by the wire on the transmitter. By the wire on the transmitter. This wire is pulling the transmitter. صح? It's pulling the transmitter to keep it stable. So the force T, the tension T, would be directed ازاي؟ upwards or downwards. لا تقولي لا, not, it's not upwards, it's not pushing, it's pulling. It is pulling the transmitter. صح? It's keeping it in place. Yeah, this is force T. This is force T. Okay. طيب. Force T produces a moment on the transmitter about the base. Describe how the moment produced by T is calculated. And indicate on figure 4.1 what is meant by any other terms in this description. طيب. What is moment? Oh, يعني how the moment? How can you calculate the moment? How can you calculate this moment? والله moment is force times perpendicular distance. صح? Moment force times perpendicular distance. طيب. So we have the force. Let me see. What did he say? Draw a perpendicular distance from the base. Yes, exactly. Yes, you should draw a perpendicular distance from the base. برافو عليك. That is the distance. ما هو where is the pivot? Force times perpendicular distance to the pivot. Where is the pivot? The pivot is at the base. Okay, so the pivot is at the base. Let's say that the pivot is here. This is the pivot because it will tilt on either side if you want to find the moment. So the distance or the perpendicular distance is, oh, this is the perpendicular distance, D. صح? This is the perpendicular distance, D. Force times perpendicular distance. That's it. That's all you need to do. Okay? This is F, let's say F, okay? Force times perpendicular distance. يبقى احنا هنا we need to write down moment equals force times perpendicular distance. Okay. 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 يلا page 155. بيقول لي ايه define moment. يلا we can define moment يا شباب. That's easy. Force times perpendicular distance to the pivot. صح. Force times perpendicular distance times perpendicular distance to the pivot. ماشي. The rod is held stationary by a horizontal force acting as shown. The mass of the rod is 0.08 kilograms. The weight of the rod. Can I find the weight of the rod? Yes, we can find the weight of the rod. W equals mg. 0.08 times 9.8. صح? 0.08 times 9.8 is what? Is 0.784. 0.784. Okay? Yeah. Can I find the moment of W about the pivot? Yes, I can find the moment of W about the pivot. Moment equals force times perpendicular distance. صح. الforce is what? Its force is 0.78. What is the distance? والله the distance يا مستر is 0.75 divided by 2. Is that correct? ها؟ لا. 0.75 isn't a perpendicular distance. It's a parallel distance. Okay, you need the perpendicular distance, which is 0.25. Okay, 90 degrees. Okay, 90 degrees. So this is the only perpendicular distance. Okay, um, so 0.78 times 0.25, yeah, is 0.195. 0.9495 newtons dot meter. طيب, the moment of F about the pivot. Moment of F about. Can you find the moment of F about the pivot? Yes, I can find the moment. Why? Because this rod is in equilibrium. The rod is in equilibrium. طب يعني ايه the rod is in equilibrium? يعني the clockwise moment is equal to the anti-clockwise moment. This W, this weight is exerting a clockwise moment, and therefore the F would exert an anti-clockwise moment. These two moments would be equal. So basically, it's the same number. It is the same number. Okay? Why? Because it's in equilibrium. طب يا مستر, how did you know it's in equilibrium? Because the rod is held stationary. Okay? It's not moving. Stationary meaning that it's not moving. طيب, can I find the force F? Yes, I can find the force F because moment is equal to force times perpendicular distance. صح? To find F, it would be moment over perpendicular distance, which is يلا 0.195 over the distance. The perpendicular distance of F is 0.75. صح? 0.75. يلا. Divided by 0.75 would be 0.26 newtons. صح؟ 0.26 newtons. يلا, I guess that's easy. طيب, next question بقى is asking you, can you find the angle? Oh, now the angle between the rod and the vertical is increased. I've increased the angle between the rod and the vertical. State whether the force F needed to hold the rod station must be increased, decreased, or stays the same. Or should it stay the same? The angle is increased. يعني ايه the angle is increased? Oh, this angle 34 is increased. Becomes a 35, 37, 40, whatever. صح؟ يعني basically this rod is being moved upwards a bit. This rod is being moved upwards a bit. What happens? What happens to the force F? What happens to the force F? والله, the force F, I think. والله, it should decrease, it should increase. No, it will increase. Why will it increase? Why will the force F increase? Now, can you find the distance between the center of mass and the pivot? Yes, you can find the distance between the center of mass and the pivot. Oh, where is the center? This is the distance. This was the center of mass. So the distance is not 0.25, it has increased. It has become 0.3, 0.4. So the distance is increasing between the center of mass and the pivot. Distance is increasing, therefore the total moment is increasing. Total moment is increasing. So force F needs to increase. يلا, force F, force needs to increase. Why? Because the perpendicular distance between the center of mass and the pivot increases, and the pivot increase. طيب, okay? Yeah, I guess that's enough for moment. That's enough for moment. Moment was an easy lesson يعني يا
Sir,
حبيبي. أيوه.
can I see the last answer?
Force needs to increase because the distance or the perpendicular distance between the center of mass and the pivot increases. Okay? طيب, يلا, let's move on to momentum. Momentum is a really, really interesting session. Okay? Momentum. Momentum is a vector. Momentum is a vector. What is a vector, يا شباب? A vector is a quantity that has a magnitude and a direction. And being a vector is one of the most important properties of momentum. Why? Because whenever you have a vector, you really care about the direction. Okay? Direction is crucial يا شباب for the momentum. Why? Because دلوقتي, can you calculate momentum? Yes, I can find the momentum. P. Momentum is P. P equals mv, mass times velocity. Mass times velocity, and you cannot say mass times speed. Mass times a velocity. Why? Because the velocity is a vector, and therefore the momentum is a vector. The velocity, if it's positive, so the momentum will be positive. If the velocity is negative, the momentum will be negative. طب how can you find, or how can you have a positive velocity or a negative velocity? It has to do with the direction of this object. It has to do with the direction of the object. خلي بالكوا يا شباب المومنتم الماس has to be in kilograms. It must be in kilograms. The velocity, it must be in meters per second. Okay, it's a must. SI units خلاص kilograms and meters per second. Momentum يا شباب, if an object, okay, if a ball hits a wall, okay, that we have a wall and this ball is moving in this direction, okay, let's say that the mass is 2 kilograms. It's moving at a speed of 10 meters per second. It hits the wall and goes back, okay, at the speed of 10 meters per second. Can I find, oh, it has the same momentum? No, it doesn't have the same momentum. It does not have the same momentum. Why? Because the direction has changed. Whenever you change the direction, whenever يا شباب you change the direction, the momentum changes. It's the same value. Okay, it could be the same value, but one of them is positive and the other one is negative. يعني ايه؟ دلوقتي if you're moving to the right, so you have a positive velocity. If you're moving to the left, you have a negative velocity. خلاص, and that's it. If you're moving to the right, positive. If you're moving to the left, a negative. So I can find the momentum. Yes, you can find the momentum. In the first one, P equals mv, so it's 2 times positive 10, which is 20 kilograms dot meters per second. صح؟ طب what about the second one? P equals mv, which is 2 but times negative 10. Negative 10, which would be negative 20 kilograms dot meters per second. Okay, you have two different values. طيب, why is this important? Because we need to find the change of momentum. Okay, we need to find the change in momentum. The change in momentum would be the impulse. The change in momentum would be the impulse. So what is the impulse يا شباب? It's the change in momentum. Impulse is the change in momentum. يعني the change in momentum, which is mv minus mu. What's the difference between v and u? V is the final velocity and u is the initial velocity. This is the final velocity and u is the initial velocity. صح? Final and initial. This is the impulse, the change in momentum. You can also find the impulse by calculating F times t. So I can also say that impulse is force times time. Of course, the force has to be newtons, must be newtons, and the time has to be in seconds. Must be in seconds. So basically, you can say that the impulse, okay, we can write down an equation, okay, Ft equals mv minus mu. One of the most important equations that we will be using in this lesson. Ft equals mv minus mu. Final momentum minus initial momentum. Okay, it's the change in momentum. And that's why we said that we can find the force by saying, well, the force is the rate of change of momentum. Rate of change of momentum. We can find the momentum and divide it by the time. Rate of change of momentum. Type. This is the impulse. So if I want to find the impulse of this ball, I would say negative 20 minus 20. Negative 20 minus 20, which would be negative 40 kilograms dot meters per second. We can also say that the impulse, the unit of the impulse, it could be either kilogram dot meter per second or newtons dot second. We have you have two units. You have two units for the momentum. You can use either. You can use either while calculating. You can use Newton dot second or you can use kilograms dot meters per second. Okay, both of them are correct. Force times time equals mv minus mu. This is the impulse. The impulse is when one object hits a wall or one object it changes its velocity or whatever, it comes to a stop or it starts moving, it was at rest and it starts moving, whatever. Okay, so impulse, we're talking about one object. one object. It's only one object. It's moving. Okay, it starts moving. It stops. Whatever it changes its motion. Whenever it changes its motion, there's a force applied on it. It accelerates. So it could accelerate, and you can find you can find the acceleration, you can find the time, you can find the initial speed, the initial velocity, the final velocity, the time. You can find too many things. This is a really, really important equation. This is if you have one object. What happens if you have two objects? These two objects collide. In in collision, okay, in collision, we say that the total momentum of these objects is conserved. Total momentum, okay, total momentum is conserved. يعني the total momentum is conserved. Total momentum is a total momentum is يعني كلمة total momentum is conserved means that the momentum before the collision is equal to the momentum after the collision. Momentum before oh momentum before is equal to the momentum after. صح? Momentum before is equal to the momentum after. So if I have two objects, okay, object 1 and object 2, this is colliding with the other object, the total momentum is conserved. So after the collision, if you have two objects, one of them moving in the other direction, for example, and the other one is moving this direction, whatever, I don't care if the first one was at rest, whatever, the total momentum is conserved. طيب. Total momentum is stop. Can I find the momentum of each object? Yes, you can find the momentum of each object. We'll say name this object M1 and this one is M2. M1 and M2. Before the collision, each object would have a velocity. So we will call these velocities U. So this object has a velocity of U1, and this object has a velocity of U2. After the collision, final velocity v1. This has a velocity of v2, v1, v2, u1 and u2. So can I find the total momentum? Yes, I can find the total momentum. All I'll do is just write the equation 4 times. m1 u1, m1 u1 plus m2 u2 equals m1 v1 plus a m2 v2. That's it. That's it. Okay, M1 U1, M2 U2, M1 V1, M2 V2. Before the collision, after the collision. You just need to find out. Okay, you just need to write down each number you have in the question. Okay, you have to write down the givens. What are the givens? What are the givens? عشان sometimes the givens are written down in a way in which you might write them down or write مثلا V is U or V1 is U1 or V2 is U whatever. Okay, so you need to carefully read each question and figure out what are the exact givens you have in this question. Okay, so M1 U1 plus M2 U2 equals M1 V1 plus M2 V2 before and after. There's a special case. Okay, there is a special case. This special case is what? Is when these two objects stick together. If these two objects stick together, let me write it down here. If they stick together after the collision, طبعا, not before the collision. After the collision, if they are sticking together, this means that they have the same velocity. They have the same velocity. So basically, I can consider them to be one object. You can consider them to be one object of one mass, one huge mass. Okay, this mass is equal to m1 plus m2. It's a bigger mass. It's okay. So this mass is equal to m1 plus m2, and they both have the same velocity v. They both have the same velocity v. So I can rewrite the equation. You could just simply rewrite the equation m1 plus m2, m1 u1 plus m2 u2 is equal to m1 plus m2 small m, okay, m1 plus m2 times v. That's it. Times v. V1, V2 لا ما هو they both have the same velocity. We don't have V1, V2. It's the same V. It is the same V. But that's why we can add M1 and M2. They're both the same. They both have the same velocity. We can consider them to be the same object. Okay, it's a new, bigger object. That's it. Okay, this is the only one of the very few rare cases in momentum. The total momentum is conserved still. The total momentum is conserved still. What I need you to understand about momentum is what? Is that when you have the total momentum, if the total momentum is conserved, if the momentum of object 1 decreases by 1000, then the momentum of object 2 will increase by 1000. If the momentum 1, for example, if the momentum of object 1 was 10,000 and it becomes 0, okay, if it was 10,000 it becomes 0, so automatically object 2 will increase by 10,000. That's it. Okay, the whole thing is in يا شباب the total momentum is conserved. The total momentum is conserved. If you decrease you will increase, if you increase you will decrease. بس خلاص. طيب على فكرة هو this is هو ده كده momentum. That's all I need to say about momentum. This is all I need to say about momentum. It's a vector quantity, positive or negative. يا شباب you must write down if you have positive values or if you have negative values. Why? Because the final answer, the final answer indicates whether it's moving to the left or moving to the right. It indicates if the force on this object is to the left or to the right or up or down. Whatever بقى يعني you can say that upwards is positive and downwards is negative. Whatever, I don't care. خلاص. But the final answer would tell you the direction of the force on this object. Would tell you the direction of the velocity of this object. Okay? Will tell you too many things about this object. That's why you need to specify the directions. Positive يعني to the right, negative is to the left. مثلا okay, you can say other words other way, yeah, it doesn't matter, it doesn't matter, but you have to specify, you have to just write it down in front of you while solving the question. Okay. um Okay, but let's solve a couple of questions regarding the momentum. Let's solve a couple of questions regarding the momentum. Let's start from hmm. Hmm. يلا. Last question momentum was page hmm. يلا. هنا there's a question I need to tell you which is cancelled. Okay. يلا. Last question momentum was page 185. Page 185. يلا بينا. Okay. كله فتح 185. طيب يلا. Explain in words what is meant by the term impulse. What is meant by the term impulse? والله impulse is the force times time. بس that's it. Yes, that's it. A force أهو times time. طيب calculate the resultant impulse. I have a balloon. Okay. It had some air in it. As the air leaves the balloon experiences a force. As the air leaves to the left, the balloon moves to the right. صح? That's like recoil. صح? It's the same concept. If the air is moving to the left, so the balloon will move to the right. If you had the rifle, if you had a gun, and the خلاص if you shoot the gun خلاص the gun will move automatically backwards. صح? That's the whole point. If you have one object moving to the left, the other object will move to the right. Why? Okay? Why? Because the total momentum initially, let's let's figure out what was the total momentum initially. The balloon, it had some air inside it خلاص. Initially they were at rest. صح? They were at rest. So initially the total momentum was zero. Velocity was zero. Velocity was a zero. But initially the momentum was zero. Therefore, after the collision بقى after whatever happens after the air leaves the balloon, what happens? The air has a negative momentum and the balloon would have a positive momentum. If you add up these two momenta, what will happen? The total momentum will remain zero. Let's calculate the resultant impulse on the balloon while it's accelerating. Type impulse equals a force times time. Equal طب ماشي force times time حاضر اوكي. can I find the force او can I find the time؟ طيب I don't have the force. يا مستر I don't have force. لا I don't have force. طب do you have a time؟ I have 0.18 seconds. ماشي. It travels a distance of 0.67 meters. صح؟ The balloon accelerates from rest until it reaches a constant speed. This constant speed, so it will accelerate, it will reach this constant speed. It then travels 0.867 meters in 0.18 seconds at this constant speed. So I found you you found this a constant speed. Can I find this speed? Yes, you can find the speed. Yeah, how can I find the speed? Speed equals distance over time. صح? Speed equals distance over time. طب this is easy. يلا يا مستر, let's solve speed equals distance over time. Speed equals distance over time. يلا, distance is 0.67 and time is 0.18. طيب 0.67 divided by 0.18 is 3.72 3.72 meters per second. طيب what does this have to do with impulse؟ انت you're saying that impulse force times time ومش عارف ايه يعني. what does this have to do with whatever you're saying؟ impulse is what? What is impulse؟ it's the force times time. طب I don't have force, I don't have time. طب can I find it using the other equation؟ change in momentum. Oh, you can find it using change in momentum. mv minus mu. صح. You can find it using mv minus mu. What is v? The final velocity. Oh, we found the final velocity. طب what is mu? The initial velocity. طب what was the initial velocity يا مستر? It was at rest. Huh? It was at rest. So mu is zero. Impulse, impulse equals mv minus mu. This is zero. يلا mv minus mu. The mass is 15 grams. خلاص يبقى 15 times 3.72. لا, that's wrong. You can't use 15 grams. You cannot use 15 grams. You need to change this to kilograms. يبقى 0.015 kilograms. صح؟ 0.015. يلا. 0.015 times 3.72 would be كام بقى؟ 0.015 times 3.72 is 0.0558, which is 0.056. Okay, 0.056. Again, do not forget the unit. You can use Newton seconds or you can use kilograms dot meters per second. صح؟ طيب. Explain how momentum is conserved as the balloon accelerates. And I just explained it. How is the momentum conserved? How is the momentum conserved? دلوقتي the air, I told you the air is moving to the left. So it has a negative momentum. And the balloon is moving to the right, so it has a positive momentum. But both of these momenta are equal. Both of these momenta are equal. The momentum of the balloon is, let's say, 0.056 positive. So the momentum of the air is negative. Momentum of the air is negative. بس يبقى the air momentum of the air is equal to the momentum of the balloon oh, but in the opposite direction. But in the opposite direction. So basically, if you add them up, they'll give you zero. صح? If we add them up, it would be برضو zero. صح? Okay. حلو جدا. يلا. This is a nice question. I guess we solved it together before بس يعني let's solve it again بسرعة كده. Can I find the change in momentum of the ball while it is in contact with the racket؟ طب change in momentum is what؟ change in momentum mv minus mu. صح؟ mv minus mu or force times time. mv minus mu or force times time. طيب يلا يا مستر. mv minus mu. The ball hits the racket at a speed of 52 meters per second. صح؟ 52 meters per second. There's a force of 350 newtons. The speed of the ball after it leaves the racket is 26 meters per second. صح؟ طيب يلا mv minus mu, so it's the mass is 58 grams. يلا we need to change this mass to 0.058 kilograms. صح؟ طيب يلا 0.058 times 52 minus 0.058 times 26. Is that correct? تقولوا لي لا, that's wrong. Why is it wrong? Because the direction has changed. So you have to use, for example, 26 is negative مثلا. طب Mr. What happens if I use the 52? If I said that it was negative 52 and positive 26, would it differ? No, it wouldn't differ. It wouldn't differ. Okay? The final change in momentum would be positive or negative. It doesn't matter. We will ignore the negative sign. We will ignore the negative sign. So it doesn't really matter. Okay? يلا MV, so it's 0.058 050 times V, which is negative 26, minus 0.058 times 52. صح؟ يلا the final momentum will be around 4.5. صح؟ This would be negative 4.5. صح؟ طب negative 4.5, should I write it down as negative 4.5? لا, write it down as 4.5. Just ignore the negative sign for now. Ignore the negative sign. يلا. Kilograms dot meters per second. تمام؟ يلا. Any questions? 4.1, are you sure it's 4.1 not 4.5? ها, no, yes, no, A. Are you sure it's negative? You're saying it's 4.1. Let me calculate it again. Maybe I 0.058. Okay, times 26 minus 52. Negative 4.524. Hey, check your calculator. طيب, okay. يلا بينا. State an equation which defines impulse in terms of force and time. يلا, impulse equals force times time. خلاص. Impulse equals force times time. يلا, let's write it down. يلا, impulse equals force times time. طيب, calculate the time that the racket is in contact with the ball. Time. طيب, force times time is impulse. We found the impulse, which is the change in momentum. A change in momentum is impulse. So خلاص, we found the impulse. Can I find the time? Yes, the time would be equal to the impulse over the force. خلاص, it's as simple as that. The impulse is 4.5 and the force is 350 newtons. صح? 350 newtons. يلا, 4.5 divide by 350 newtons, which is 0.012. طيب, 0.012, not 0.12 seconds. If your impulse was negative, okay, if you left it as negative 4.5, which wouldn't have been wrong yet, but if you left the impulse as negative 4.5, then you would have found the time to be negative 4.5 over 350, which is negative 0.012 seconds. The ball has moved back in time. So the ball is a time traveler, so, which is definitely wrong. If the force was if the impulse was negative 4.5, the force needed to be negative 350. The negatives need to cancel out. Okay, that's it. Calculate the difference between the values of the kinetic energy. طيب, we haven't we've said kinetic energy before. يلا, half mv squared minus half mv squared. You have to calculate it this way. Now we will discuss kinetic energy later on, but you have to write it down as half mv squared minus half mv squared, which is basically half times 0.058. Okay, 0.058 times 52 squared minus half times 0.058 times 26 squared. صح؟ طب يا مستر it was negative 26. It's okay. You can write it down as negative 26 بس between brackets, so it would be positive برضو. Negative 26, okay? Squared. The total of the change in kinetic energy would be around 59 joules. Okay? 59 joules. Easy, صح? Huh. Any questions up till now? يلا بينا. Ah, let's solve this question. This is an easy question. يلا. Car B has a mass of 800 kilograms. يلا. 800 kilograms. Moving at a speed of 2 meters per second. Car A, mass 1000 kilograms, which is stationary. So the initial momentum of car A was 0. The initial momentum of car B was 1600. After the collision, car A moves at 1.3 meters per second. After the collision, both cars travel in the same direction as the initial direction of B. Because car B hits car A, show that the speed of car B after the collision is approximately 0.4 meters per second. But this question, are they both sticking together? لا, they're not sticking together. صح? Well, how do you know that they're not sticking together? Because car A has a speed of 1.3. Car B should have a different speed. We need to find this different speed. We need to find out that it is in fact 0.4 meters per second. Let's write down the equation. Huh? M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. Yeah, mass of car B. Let's say in car B was mass 1. 800 times U1, which is 2, plus M2 U2 car A, which was at rest. So it's basically 0. Equals M1 V1. We need to find V1. We need to find the velocity of car B. You need to find the velocity of car B. So we'll assume that we do not know it. It's around 0.4. So mass 1, 800 V1 plus M2, which is car A, 1000, times the velocity of car A, which is 1.3. يلا, let's calculate it. هنا it's 1600 equals 800. V1 plus 1300. يلا, minus 1300. So 300 is equal to 800 V1 divided by 800. So V1 is equal to 0.375 meters per second, which is very close to 0.4 meters per second. صح? Very close to 0.4 meters per second. Easy? Can you find the impulse exerted by A on B? Can you find the impulse exerted by car A on car B? You need to find the impulse of what? You need to find the impulse of car B. You need to find the impulse of car B. طيب, what is the impulse of car B يا مستر؟ how can you find the impulse of car B? What ايه ده؟ ايه اللي انت بتقوله ده؟ هو دلوقتي if you want to find the impulse of an object, it's the change in momentum of this object. صح? It's the change of momentum of this object. We need to find the change of momentum of car B. خلي بالكم. We need to find the change of momentum of car B. Initially, car B had a velocity of 2. Finally, the car B had a velocity of 0.4. Can you find, or actually 0.375. Can you find the change in momentum? Yes, you can find the change in momentum. You can ازاي mv minus mu. mv minus mu. طيب يلا mv minus mu, which is 800 times 0.375 minus 800 times 1600. Sorry, times 8 times 2. I'm sorry. Okay, times 2. صح? It should give you 300 newtons dot second or kilograms dot meter per second. بس that's it. طيب يا مستر I thought about it. I didn't solve it this way. I thought about it. Initially, car B had a momentum of 1600. صح? And car A had a momentum of 0 Initially, car A had a momentum of 0. Finally, car A had a momentum of 1,300. Finally, car A had a momentum of 1,000. So car A increased by 1,300. Therefore, car B must decrease by 1,300. So 1,300. And I forgot the one. Okay, so A increased by 1,300. B must decrease by 1,300. It must be the same number. Must طب state the impulse exerted by B on A. That's the same number. 1,300 newtons dot second. بس it has to be the same number. That's the law of conservation of momentum. The law of conservation of momentum. The total momentum in the system is conserved. The total momentum in the system is conserved. If you decrease هنا شوية, the other one will increase. خلاص, that's it. Okay, that is it. Type. Oh, this is the question I was telling you about. Okay, you need to ignore this question, or especially part I and double I. Okay, why? Because you're not required to find or to draw um, vector diagrams with angles other than 90. And if you have an angle of 45, you're not required to draw this angle. You're not required to draw the vector diagram of this of this drawing. Okay, if it was 90 degrees, one of them was vertically upwards and the other one was to the left or to the right. Okay, 90 degrees, we can find it using Pythagorean theorem. Yes, we can do it, and we can find the angle between them using a tan inverse. Yes, you can do that. But for this question, خلاص, it has been removed from the syllabus. Okay, طبعا you can find the magnitude of the momentum P equals mv. يعني if you want to solve part A يعني P equals mv, the mass is 0.16 and the velocity is 15, so خلاص 0.16 times 15 is whatever. Times 15 is 2.4, and again do not forget the unit, kilograms dot meters per second. بس okay بس يلا احنا we can solve this last question and that would be it for today. يلا, what is mass times acceleration? يلا, mass times acceleration is طبعا force, صح? Mass times acceleration is force. What about force times the time? يلا, this is force. Force times time is a impulse, صح? طيب, يلا, he has a golf club. The ball has a mass of 0.046 kilograms and contact with the ball for 5 times 10 to the power of negative 4 seconds. It leaves the ball at a speed of 65 meters per second. صح. Can you find the momentum of the ball as it leaves? Yes, I can find the momentum. P equals mv. You have the mass and you have the velocity. يلا. P equals mv, which is 0.046 times the velocity, which is 65. صح. This would give you a final answer of around 3 kilograms dot meters per second. بصوا يا شباب, time is 5 times 10 to the negative 4 seconds. 5 times 10 to the negative 4 seconds. He could, okay, 5 times. What is 5 times 10 to the negative 4 seconds? Okay, yes, 5 times يعني 0 point, يعني 0 point, يعني we can change 1 2 3 4 صح كده؟ نحط البوينت هنا 5 seconds صح. Sometimes, well, actually, this is quite he probably will do that. He wouldn't give you the time in 5 times 10 to the negative 4 seconds. Actually, he will say that the time is 0.5 ms. 0.5 ms. What is 0.5 ms? M is milliseconds. M is milliseconds. Okay, there's a high chance that he will give you the time in ms, or he could say for another question, the time is 3 microseconds, which is times 10 to the negative 6, or you could say, let's say 7 ns. Okay, not capital N, small n. Ns, what is ns? Nanoseconds, which is times 10 to the negative 9. Okay, there's a very, very high chance that he would use one of these prefixes in your actual final exam. Anyway, but for this exam, it's 0.005 seconds or 0.5 milliseconds, which is times 10 to the negative 3. 0.5 times 10 to the negative 3, which is again 5 times 10 to the negative 4. So he is correct. Can you find the resultant force? Yes, I can find the resultant force. What is the resultant force? Force equals force. To find the force is impulse over time. To find the force is impulse over time. You have the impulse, which is the change in momentum. Ada, do you have the change in momentum? Yes, I do have the change in momentum because initially the ball was at rest. صح? Initially the ball was at rest, and finally the ball has a momentum of 3. So the change in momentum, the impulse, is 3 minus 0. صح؟ 3 minus 0, which is basically 3 over 5 times 10 to the negative 4. 5 times 10 to the negative 4. يلا, can you find the average force? Yes, طبعا. Okay, let's calculate it يا شباب. It would be كام؟ Okay, it would be around 6,000 newtons, صح؟ Around 6,000 newtons, صح؟ طيب يلا, last but not least, hey, yes, 6,000. طيب, when the golf club is in contact with the ball becomes compressed and changes the shape. State the type of energy stored in the ball during contact. Yeah, what is the type of energy stored inside the ball while it changes its shape? طبعا elastic potential energy or strain potential energy. You can say either. Elastic potential or strain. Elastic, or you can say strain potential energy. Okay? Okay, that's it.